Hello learner, I am Ajay Kumar, Assistant Professor, Department of Computer Science and Informatics, Central University of Himachal Pradesh. Today we will study about the introduction to algorithm, that is your block 1, unit 1 in your course of algorithm design. So these are the content. First we will talk about what is the definition of algorithm and some related examples and the characteristics of algorithm, and at last we will discuss about the steps in designing of algorithm, right. So what is the definition of algorithm? Before diving into the algorithm part, first we will see the definitions related to, like you can see this kind of definition is available in your book also. An algorithm is a well defined sequential computational techniques that accepts a value or a collection of values as input, okay, and produce the output or outputs needed to solve a problem. When we start about when we want to solve a problem, first we have to give some input or a collection of inputs, you can say collection of values also, then we will get some output, okay. So in simpler way, the definition of algorithm is, an algorithm is a set of steps, you can say set of steps means unambiguous steps for solving a problem. Most algorithm follow these steps, that 4 steps. First is input. Input means it generally required a finite number of inputs, it may be 0 inputs, but it should be finite, 0 or more inputs. Second requirement is output, it must produce at least one output, okay. Uniqueness, each instruction should be unambiguous. Unambiguous means there should not be any kind of ambiguity in any of the steps, okay. And the last is finiteness, the number of steps must be finite. The number of steps must be finite means the terminating time should be finite. So some steps of algorithm may run repeatedly, that is in looping conditions, but in the end termination is what ends an algorithm in finite time. So what is the analysis issues of an algorithm? When we think about to solve any problem, so what kind of issues first came in our mind? So analysis of algorithm is a field of computer science whose overall goal is an understanding of the complexity of algorithm in terms of time complexity or space complexity. So before solving any problem, first we think what data structure to use, either it will be linked list or array or stack or queue, heaps. There are many data structures are available. And the second step, is it correct? That means we think about each steps before solving a problem, is it correct? Second, how efficient is? Efficiency means we can think about the time and space complexity. And is there any efficient algorithm? That means here the comparison will start. Either it will be solved in finite time or infinite time, or it may be logarithmic time or linear time. So efficiency terms basically in finiteness or the time comparison of time, okay. So the main concern about this any kind of algorithm, we should think about the time complexity and space complexity. So writing an efficient algorithm helps to consume the minimum amount of time for processing the logic. Let us suppose algorithm A, and it is just based on the 2 parameters if we have an input size n. So first is time complexity. So time complexity means time taken by algorithm to solve the problem. So it is measured by calculating the iteration of loops, either it will be arithmetic conditions also, or like iteration, or the number of comparison it may be possible. So first is time complexity, second is space complexity. Space means that is memory space. So space taken by the algorithm to solve the problem, it includes a space used by necessary input variable, that means it may be array also, and any extra space. When we like in case of recursion we use a stack. So a stack is like extra space. So this is an extra space occupied, hence will count towards the space complexity of the algorithm. This extra space is known as the auxiliary space also. Next here few examples related to the time complexity, how to calculate the time complexity. In first example, here you can see there are 3 variable a, b, c, and the value of a plus b is assigned into c, and the printf statement is there. So, here only one statement, that is c equal to a plus b, that is arithmetic expression adding of two variable a and b and assigning to c. Here it will take constant time, that is time complexity is constant. Okay. In the second example, here the count in array having n elements. So, this array, this for loop, here in this count function there is a for loop and it is iterative, that is 0 to n. So, how many times this for loop executed, that is 0 to n minus 1, that is n times. So, overall time complexity of this example is order of n. Third this in this example, here you can see there is a for loop and within the for loop one more for loop is there and here printf ignu. So, how many time ignu is printed? So, for every iteration outer loop of I, there will be n iteration, okay, for inner for loop, and their outer for loop having n iteration. So, n into n, that is n square. So, time complexity is order of n square. In this fourth example here, here for loop is there, but the incremented value is I equal to I square. So, every time the value will be square. So, PGD line will be printed how many times. So, here the jump statement, that is jump statement is I square. I square means if I equal to 1, that is 1 square, if I equal to 2, that is 2 square, then 3 square, then 4 square. So, every time the jumping will be higher. So, if we compare 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3 like this. So, we can and after adding such statements, we can get the log n time complexity. Okay. So, here in fifth statement, fifth example, here you can see here is also a for loop, but the incremented value of I equal to power of I to the power 2. So, here it will start from 2. So, 2 to the power 2 and when I equal to 3. So, this value will be squaring each time. Okay. So, in this case you can calculate the time complexity order of log n. Here this is the for loop, this is while loop, and this while loop is belonging to there will be two kind of search, linear search and binary search, and this while loop is used in binary search. So, every time here you can see n is less than array of mid and high equal to mid minus 1, else if n greater than array of mid and low equal to mid plus 1, that is the algorithm used in binary search. And every time you can see low is less than equal to high, here in while loop this complexity is log of n, because in binary search the total iteration is log of n, and if you count every time the problem statement is n by 2. Every time the problem statement is half, the length of problem statement will half. So, you can get the time complexity order of log n. So, meaning of complexity function. What is the meaning of complexity function? The complexity of an algorithm M is the function of Fn, which gives the algorithm's runtime and storage space requirement in terms of the size n of the input data. Frequently, the storage space required by an algorithm is simply a multiple of the data size n. So, the term complexity given anywhere generally refers to the algorithm's running time. So, there are three cases where we can find the complexity function, that is first is best case, the minimum Fn value, Fn is any function for any possible inputs. It may be input size will large. So, the best case will be the minimum value of Fn, and the worst case is maximum value of Fn for any possible input. Okay? And the average case is the value of Fn which is in between maximum and minimum for any possible input. Generally, the average case imply the expected value of Fn. Okay? So, here is the example of because here I am discussing about the best case, worst case and average case. So, here I have taken the example of linear search. Here input is a linear list A with n elements and searching element x. Okay? So, what should be output? We need output of location, find the location LOC of in the array A, okay, or return LOC 0 to indicate x is not present in the array. So here while loop is there, where LOC variable is equal to 0 and k is less than n. Every time we compare that value x to the each element of the array. Okay, whenever we get x equal to ak, then we store the location of that value in the array. And if at the end of while loop, if we LOC value is not updated, that means x is not present in the given array, and else x is present in the given array, and we can get the location through the value of k. So finally end the algorithm. So here we want to discuss the best case, worst case and average case. In best case, the complexity of the search algorithm. In best case, what will be the best case? When element is counted at the first position of the array. Okay, the best case occurs when x is the first element of the array. At that time, what will be the value? That is 1, that is constant time. Okay, and in worst case, what will be the worst case? In worst case, when x is the last element of an array or x is not present in the array. So we have to search every element of the array. So if we assume the n element, because here in this input side here n elements are there in this array, so we have to traverse or we have to comparison. How many comparison? That will be the n comparison. So in worst case, the time complexity will be n. In average case, so in average case, what will be the conditions? So we assume the search element x appear in an array and is equally likely to occur at any position in the array. Okay, so here the number of comparison can be any of the positions 1, 2, 3, n, and each numbers occurs with the probability p equal to 1 by n. So every position 1 to n, there will be how to calculate the number of comparison? That is 1 into 1 by n, 2 into 1 by n, that is n into n by n, and finally we can get the n plus 1 by 2, that means order of n comparison. Okay, so in best case we can get the order of 1 comparison, in worst case order of n comparison, in average case also we can get the order of n comparison. So these are the basic techniques for designing an efficient algorithm. If we have a designing strategy, divide and conquer. So what is the problem related to that? That in case of binary search, we can use the divide and conquer principle. In case of heap sort, we use the divide and conquer principle. In case of merge sort, we use the divide and conquer principle. Similarly, in greedy method, that is a knapsack problem. 0-1 knapsack will be used in dynamic, and there is just Dijkstra's algorithm, Kruskal algorithm, Prim's algorithm, all is the part of the greedy algorithm. And all pair shortest path Floyd-Warshall algorithm, 0-1 knapsack traveling salesman problem will solve through the dynamic programming. N-Queens problem solved through the backtracking. Assignment problem, TSP problem, that will be solved. TSP problem actually solved in dynamic way and branch and bound also. So these are the types of algorithm. What are the types of algorithm? So there are several types I am going to cover. That is, the first is brute force algorithm. It is the most straightforward approach for a problem. That is, you can say, the layman approach. Okay, when we think about any problem, solution of any problem, first we think about the brute force approach. Okay, the second is recursive algorithm. Recursive algorithm means it is in this case a problem is repeatedly broken into several subparts and call the same function. Actually, when we find the factorial of a given number, we generally use that is recursive functions. Okay, so that we can get the every time if we want to find the factorial of n. So for finding the factorial of n, we get the factorial of n minus 1, n minus 2 up to the factorial of 1 or 2. Okay. Next is backtracking problem, backtracking algorithm. So backtracking algorithm builds the solution by searching all possible solution. So using this algorithm, we keep on making the solution following the criteria. Whenever a solution fails, we track back to the failure point and build on next solution and continue this process until we find a solution or all possible solution are looked after. Actually, backtracking means when we think about the solving a problem, we go the n possible ways, and when after moving ahead and we realize that this problem is not solved in this way, so we go to the failure point and go to the next possible ways. So backtracking means we think any problem can be solved in a multiple ways and backtrack, and we will find the actual solutions. Searching algorithm, we know there are two kind of searching algorithm available for this course, that is linear search and binary search. Sorting algorithm, there are many sorting algorithm, bubble sort, insertion sort, selection sort, merge sort, there are lots of searching algorithm are there. Hashing algorithm, basically in hashing algorithm there will be two things, key and value. Key value pair we find in hashing algorithm. Divide and conquer algorithm, this algorithm breaks a problem into sub problems. Solve a single sub problem and merge the solution to get the final solution. It consists of the following three steps. First, divide the problem. Divide till we get the problem size will be like 1 or 2, and solve that problem size, and combine after solving that lowest problem size, and at each step we combine that solutions, and finally we get the problem of that solution. That means in divide and conquer we generally divide the big problem into the single sub problem, okay, and finally we get the solution of single sub problem and combined it, and we can get the larger solutions, larger problem solutions. Next is greedy algorithm. This solution is built part by part. In this type of algorithm, the solution for the next part is built based on the immediate benefit. Actually, in greedy terms means, greedy means when we greed something. So, greeding means when we solve any problem, we can approach, we can think about the greedy, and after the one solution giving the most benefit will chosen to the next part. And the dynamic problem, in dynamic programming problem, this algorithm use the already found solution to avoid the repetitive or calculation of the same part of the problem. It divides the problem into a smaller overlapping sub problem and solve them. So, after getting the solution of overlapping sub problem, we can use that solution to the next round. Next is what is the need of algorithm. So, algorithm are used to solve problem or automate task systematically and efficiently. So, there are several reasons why we use algorithm. First is problem solving. Being able to write an algorithm improves your problem solving capacity. Okay. So, when we think about any problems and we try to solve that problem, in this way we can improve our skill through the problem solving. And scalability, an algorithm helps your software application or website respond appropriately to demands, because when we developed any software or any website, earlier we don't know the hit count. When the hit count is increases, at that time we have to think the algorithm to be scalable. So, problem utilization of resources, in this way also there is a requirement of algorithm. So, choosing the right algorithm ensure proper utilization of resources such as memory, storage, network, or any and others. So, efficiency, in case of efficiency, when we compare the same solution to a given problem, we at that time we think about the efficiency. That means how that task quickly and accurately, making them essential tool for tasks that require a lot of calculation of or data processing. Consistency, in case of consistent result we need the algorithm. Automation, algorithm can automate repetitive tasks, reducing the need for human intervention and freeing up time for the other tasks. Overall, algorithm are an essential tool for solving problem in a variety of fields, including computer science, engineering, data analysis, data mining, finance, and many other scenario, real life situation we can use the algorithm. So, what are the steps in designing of algorithm? The following steps are involved in designing an algorithm. Basically, when a problem is in front of you, how you think about the solution of that problem. First, we think about the problem definition. What is the actual problem? What is the definition of that problem? Then we think about the development of a model. Okay, model means we think about the brute force approach, okay, or we can say we use flow chart, whatever way we simplify that problem. So, this part comes into the development of a model. Then when we accurately understand the problem definition and that model, we think about the algorithm. Okay, what are the algorithm? What should be the right algorithm? Then we designing an algorithm, because in a specification of an algorithm we think about the different ways. Actually, whenever a problem is solved in linear time or quadratic time or polynomial time or constant time or logarithmic time. So, in all the way we think about the solution of that problem, and when we finalize that we are able to solve this problem in logarithmic time or linear time or quadratic time, then we start the designing of an algorithm, and after designing of algorithm we check the correctness of algorithm. Correctness means for a given input we can get right output or not. Okay. So, this is very important, and after getting the result, then analysis part means time and space, time complexity and space complexity. Okay. So, for solving a problem, like when we want to search or sort a given list of an array, given list of numbers, what are the what will be the right solutions? What is the solution of that problem? So, in this case analysis matters, because when we use insertion sort or like merge sort, the complexity will be different. When we use merge sort, the complexity of order of n log n, okay, in every case. But when we use insertion sort, in that case, in best case we can get in order of n time, in worst case we can get in order of n square time. So, that analysis is important for solving any problem. And then when we finalize that the algorithm time and space complexity, then implementation means coding will be started. Okay. And after implementation or in between the implementation, we generally use the testing. Okay. The testing may be unit testing or system testing or integration kind of testing. So, all the testing procedure. Testing means for a given input, are we getting the right output or not. So, testing is also important, and at last we make a documentation. Documentation means that will be we can see in any software that is the readme file. So, readme file is your documentation part. So, these are the steps involved in designing of an algorithm. So, generally we confused about the algorithm, pseudocode and program. So, I want to specify these three terms, that is algorithm means systematic or logical approach, a well defined step by step procedure that allows a computer to solve a problem. Okay. So, algorithm means it is the systematic and logical approach and well defined procedure, that means unambiguous steps will be there. So, that is the algorithm. Pseudocode means it is the simpler version of programming. Okay. Before we, that is you can see you can write like flow chart or like layman approach for solving a simpler version of programming, that is plain English language or whatever the local language it may be possible, it may be Hindi or Odia or whatever the language. So, that will be pseudocode. And programming means when your algorithm is finalized, that algorithm you are following, then in that case it is the exact code written for a problem and following all the programming paradigms. Okay. Programming language rule. If we solve a problem in C or C++ or Java, we have to use all the construct or rules of that programming language. So, I have taken one example of linear search. When we write the algorithm of linear search, we can write in this way. When we write the pseudocode of linear search, so here we can write linear search list search item, which item you want to search for index, that is. So, this is the plain English like language, and we can write pseudocode in this way. And at last, how to write the program of linear search in C language. This search function will be there, and there will be two parameters, and you already know the how to pass the elements in any function, and the which element you have to find. So, this code will be the function of the searching of an element in an array. So, this is the three a single problem can be solved in a algorithm. This is the algorithm, this is the pseudocode, and this is the final program. So, what are the advantages of algorithm? Algorithm advantage is, first is easy to understand, because since it is a stepwise representation of a solution to a given problem. So, it is easy to understand. When we when we use pseudocode, that will be the most easiest way. Then we think about the algorithm, next level of complexity, and when we write the program, that is the implementation of that algorithm in a particular language, that is the upper level, that is the last level, because in through programming language computer can understand. Okay. So, pseudocode can be used for the layman approach. Okay. An algorithm can be used for the upper level or higher level approach, and the programming is used for the computer. So, this is easy to understand, and language when we write any algorithm, that is not mandatory for a language, because when we write pseudocode or any algorithm, there is not requirement of any language, because when we solve any problem, so we just write the simple steps, no programming language is there. Okay. And the debug or error finding, every step is independent in a flow. So, it will be easy to spot and fix the error, because earlier I have given the definition of algorithm. Every step should be unambiguous. So, every step is independent or in a flow. So, it will be easy to spot and fix the error. Okay. And the sub problem, it is written in a flow. So, now the programmer can divide the tasks, which makes them easier to code. When we use the merge sort algorithm, or when we use the divide and conquer approach of algorithm, in this case we divide the big problem to smaller sub problems, and finally the sub problem size have 1 or 2. In that case we divide a problem into the sub problem. So, what are the disadvantages of algorithm? So, creating efficient algorithm is time consuming and requires good logical skills. Bad to show branching and looping in algorithm. So, these are the disadvantages, because when we upgrade, when we solve a problem in minimum time. Suppose a matrix multiplication example I have given. So, in case of matrix multiplication, what will be the time complexity? In this case, the time complexity of order of n cube, and for reducing order of n to the power 3 to n to the power 2.67, that is a Strassen matrix multiplication, that will take lots of time, like years to solve any problem, because there are lots of challenging problems are available in algorithm, where you can there is a consuming of lots of time. So, and bad to show branching and looping in algorithm. So, this is the end of this first lecture or first module. So, overall, if I am summarizing this algorithm sections, so first we have to know what is algorithm, what are the steps involved in algorithm. So, first we have to know the algorithm, that means we should know what are the inputs, what are the outputs, and how many that steps should be unambiguous, and it will be terminate in finite time, that is the finiteness. So, we have to think the 4 things, and moving ahead, before making any algorithm, we should think about the analysis. Analysis means if a problem can be solved in many ways, and analysis part that will cover in the time and space complexity. So, if a problem is solved in minimum time or a minimum space is required, so that part comes into the analysis part. So, how to design the algorithm? So, before designing the algorithm, we have to follow first the problem statement, then problem statement to the modeling, how to model that problem or problem definition, and then what are the steps behind to solve that problem, and in middle way we have to implement that algorithm that is used by any programming language, either it can be C, C++, Java, whatever the language, and in between we should use the testing skill, that is the unit testing or integration testing or system testing, whatever the testing, and finally we make the document part. So, these are the basic unit of algorithm. So, first so overall we have to know the definitions, analysis and design. So, thank you so much.